Okay, last time we started a new chapter related to the motion, and in motion we discuss about basic states like rest and motion states. Plus, we also include two important quantities, distance and displacement. And we also discuss the questions related to distance and displacement. There is only one question that we discussed related to distance and displacement because this topic is very easy as compared to the other in this chapter. So that's why there are less questions related to distance and displacement, but we will get more from the MCQs when we practice it. And the second topic we included in last class that is related to speed and velocity, right? The third quantity we are going to include today is acceleration. And before starting acceleration, if we consider two more categories of velocity or speed, constant speed. Okay, so the meaning of the constant speed is definitely that speed is constant, but how speed can be constant? So if you want to define the constant speed idea, so we can define like when body covers equal distance in equal interval of time, right? For example, in first minute we cover 10 meters, then in next minute we also cover 10 meter. So there is equal interval of time like 1 minute, 1 minute, 1 minute, and we cover equal distance like 10 meters, 10 meters, 10 meters. So in this way, we can say that the meaning of constant speed is when body covers equal distance in equal interval of time. So this is the concept of constant speed, right? So for example, if we consider some values, let's suppose in first minute, body covers 2 meter. Then after one more minute, total distance covered is 4 meter. And in further 1 minute, 6 meter. 4 minute, 8 meter, right? So this is the scenario for a body which covers such distance in such interval of time. And let's suppose if you find out speed from all these values given, all these data set values. So for example, uh, from the first one, we can use the formula of speed. We discuss the formula of speed. Speed is equals to distance upon time. So if we find out v is equals to, so distance is equals to 2 meters divided by 1 minute, it is equals to 2 meters per minute, right? In the same way, if you compare any other value, let's suppose if you compare this value, so it is equals to Again 6 meter divided by 3 minute equals to 2 meters per minute, right? So you can see we are getting same answer. In the same way, if we consider the last value, V is equals to 8 meter divided by 4 minute equals to like this. Okay. So we are getting same answers from each data set value. So it means that speed is constant. So this is the concept of constant speed, right? Any confusion?
No, sir.
Okay. And for example, if we add one more idea in this, because we already discussed that we have a concept of scalar and vector quantities. So definitely scalar and vector quantities are also very important and we need to include them in our questions. So for example, if we consider the idea of constant velocity. So according to the constant velocity, so if you remember the difference between speed and velocity, so we have idea of scalar and vector quantity. Like speed is a scalar quantity, velocity is a vector quantity, right? So when we are writing about velocity, so it is very important uh, to include the direction idea in your definition. So the definition will be when body covers equal distance in equal interval of time in same direction. So that is called constant velocity, right? So when we are writing the word velocity, especially like in physics, so always remember that we are including direction also. In your questions, not every time we will compare like this, but we need to keep in our mind because in some questions, they ask questions in with the reference of velocity, direction, and speed with the concept of without direction. Okay. So it is not compulsory to always apply this idea in your questions because sometimes they are only asking about the magnitude, the value, the number. So direction is not important in that question. But sometimes they also ask reference to the direction of the body. Okay. So this is the difference we need to keep in our mind. So direction also remains the same. Okay. Now, if you consider another situation, for example, if you are taking U-turn, right? So when we are taking U-turn, so what do you think about the direction? Direction is constant or direction is changing while we are taking U-turn?
It's changing.
It's changing, right? So you can say that velocity is not constant. Okay. For example, taking U-turn. So when we are taking U-turn, so there are two possibilities. If we talk about speed and if we talk about velocity. So if we talk about speed, so while taking U-turn, speed remains same or it will be different?
Different.
Only speed. And what about velocity? Velocity remains same or velocity will be different? So basically speed remains the same because in speed, no direction required. And if we talk about velocity, so velocity changes because of change in direction, right? Clear? Any question in this?
No, sir.
Okay. So, whenever we got questions like this, so we can easily compare the differences between them. Okay. And now, we can include one more quantity in motion, that is called acceleration. Acceleration. So if we talk about acceleration, so any idea about acceleration, or do you know about this word, or you heard this word before? Definitely we
I
know
heard.
about this word, right? In cars or in vehicles,
Yes, sir.
there is a component called accelerator, right? So what is the
Yes,
Yes,
sir.
working?
sir.
Yes. So what is the working of accelerator in your simple words? What do you think about accelerators?
Sir, could you please scroll up? I just want to see the taking U-turn part. Thank you.
Okay. So we are talking about accelerator. So what is the working of accelerator in vehicle or in cars? In simple words, if you want to explain according to your knowledge. Okay, basically when you press accelerator in the car, or if we like take example of the bike, so when we apply accelerator in any vehicle, so what happens with that vehicle? What happens with the speed of that vehicle?
It go a bit faster.
It goes
It
faster.
increases.
Yes, it increases. And when you release accelerator, so what happens? It slows down.
It slows down.
Exactly. So basically, the main purpose of accelerator is to change speed, right? We can change speed with the help of accelerator in the vehicle, right? So it means that the concept of acceleration is also same, right? We can use acceleration concept to show the change in velocity, or like we can say to increase in velocity or decrease in velocity. Okay. So for acceleration, we can say acceleration is rate of change of velocity. Okay. So when you increase or decrease velocity with respect to time, so that is called acceleration. Okay. And the formula is like this. This V represents yes. Any question?
Sir, can you just scroll up? I just want to write something.
Can you please repeat again?
Sir, can you just scroll up? I
Okay,
forgot
okay.
to write something.
The concept of the rate or velocity. Done?
Yes, sir.
Yes. So basically, we need to compare initial and final velocity. Let's suppose if we take signal example like we are at red signal. So if we are taking the example of red signal, so what do you think about red signal when a car is at red signal? So what will be the speed or velocity of the car when car is at red signal?
Stopped.
So car is
Zero.
in rest state,
Zero.
definitely zero. So we can say zero velocity. So this is initial velocity, right? And when a signal turns to green, so this is green signal now. So signal turns into green. So when signal turns into green, so what do you think about this velocity or the speed of the car?
The car will start moving, so the speed will increase.
Yes. So definitely it is no more zero. It starts to increase from the zero value. So final velocity will be not zero. It will be moving with certain velocity. This is final, right? So in this way, we can compare initial and final velocity. And this process can be also in the reverse form. For example, if the car is already moving and now signal turns into red, so definitely car needs to apply brake and car needs to be stopped, right? So then what happens? The initial velocity of the car is greater, but final velocity will be zero. Okay. So for example, if initially we have a green signal, so if we again take in the same example, but in the reverse form, so initially car is at moving with certain speed and signal is green. So now we can say initial velocity is maximum. And when signal turns into red, So when signal turns into red, so finally what happens? Speed becomes 0. V, right? So now the situation changes. Now at green signal, we have maximum velocity, but finally we got 0 velocity. Okay, so you can compare easily. So basically, we can easily compare these two differences. In the first difference, like this is case 1, and this is case 2. Case 2. So if we consider these two different cases, so what is happening? The first case is normal acceleration. So according to the first case, we can say it is acceleration. And it is positive. But in case 2, we know that speed decreases. So when speed decreases, so that is called deceleration, and this is negative. Okay.